Team 3596, Rocket Robotics.
I'm here at the Sussex Scrimmage at Sussex Hamilton High School.
I am here with Alex McCune again. I bet you're probably sick of him. Alex, how was the first practice match, and were there any kinks in the system?
Could have gone better, honestly. We had our controllers mixed up and things were reversed that shouldn't have been reversed, but we took care of it. Our next practice match is in about 30 minutes, and I'm making sure everything's good and ready for it in code.
All right, thank you. Here with Jackson. And Jackson, how is being a human player in the first practice round?
It's fun. I feel like I'm contributing to the team and the alliance, and I feel like that it's going pretty smooth.
Nice. I'm here with
Dylan Stern, the project manager of Team 1091.
All right. Could you tell us about your guys' bot for this season?
Our robot this season is a swerve drive powered 4-bar pickup mechanism that uses 4 sim motors to shoot out at a 30-degree angle.
Is that it?
Pretty much.
All right. Thank you very much.
Yep.
Thank you. Either or.
Okay.
Are we both in frame?
Yep.
All right. Start recording. I am here with. Sorry, I already forgot.
Nathan.
All right. From Saber Robotics, and could you tell us a little bit about your bot?
So this year, this is still only our Gen 1 robot. There's still some iterations, but
we got a lot of inspiration from the unqualified quokkas, as I'm sure a lot of teams have already.
Yeah.
So we tried iterating. We're trying a lot of different things with this new robot. It's not final design, but we're getting there.
All right.
Iteration is part of the design process.
All right. That's it.
That's it.
All right.
I am here with
James Resch.
and could you tell us about your guys' bot for this season?
Yeah, we went with a swerve drive, all Falcons, and a shooter that pivots down and goes back up the pick. We did that because after all of the rims are off the floor, all we have to do is set it to the set point, go to the human player spot, and they shoot it right into our shooter so we don't try to pick up off the floor again or anything like that. And it goes back over to another encoder set point, shoots all by itself off one button. We can just keep cycling. We got 15 in a practice run at our own facility.
All right. Thank you.
Yep.
Thank you for your time.
Charlie from Team 8701 Graffiti.
Could you tell us about what's going on with the bot and how it works?
Yeah, so our robot has an under-bumper intake here. So we intake the rings underneath the bumpers here, and they go into these two rollers that bring them up, and our shooter can pivot on the back of the robot. It pivots down, so the ring gets pulled up into the shooter, and then we can pivot up and down to shoot into the speaker, into the amp, or to intake from the human player station.
Thank you.
Yep.
I am here with
Danny Boyer, Bond Brigade.
Could you tell us about the bot and how it works?
We have really basic swerve drive modules, tubular frame. It's pretty standard. There's only one moving part, the big arm. It has an intake, a holder, and the shooters, as well as climbing integrated inside the arm. It's powered using Neos. We only use Neos. It's the first designs. It's a little iffy, but it's gonna be okay. Just got off the field. It's a little bad, but that's not that big of a deal. Really simple. There's not much to it.
Thank you. Could you tell us about how the bot works?
Not really.
Not really.
Can.
Alright.
So,
A little mic.
we have a swerve drive robot, and cylinder here, and the wheels up here will spin in opposite directions so that they pick up the rings, and then we'll have an arm here that will take the rings and then shoot them wherever they need to go.
Thank you. I am here with.
Harrison from Team 6574.
Could you tell us about how your bot works?
So right now we have an intake that goes in and out like this, and it picks up the note from the ground, and we move into a transitional state, and it kind of just pauses there for a second, and we give the shooter motors a moment to speed up, and then it goes from the transition to shoot.
I'm here with.
Caden from FRC 2077 Laser Robotics.
Could you tell us about how your bot works for this season?
Yeah, so we have a plate that's has a lot of, I guess, non-slip surface on it. I don't remember the exact name of the product. We had some of it laying around. So the notes will just slide right over that. We have some compliant wheels that are underneath this plate. Those are powered by this 775 with the 90-degree on it. So that torques it in there. It's grabbed by these, and then the note basically, here, I'll set it back up for a second. After it's put in there like this, essentially, right? These motors back here, which are the new Johnson Electric ones they're sold at Anymark and a few other retailers, but those are we use as the feeder wheels. These are flywheels, they're 550s. So these will ramp up, and those will feed it through, and then we're able to score in the amp as well as the speaker. We think we can modify it a little bit to be able to consistently score in the trapdoor, but we have yet to do a little bit of testing.
Thank you. I'm here with.
Honor Caden. We're from Team 1792, Roundtable Robotics.
Could you tell us about how your bot works for this season?
Yeah, so we went with a simple, reliable, and fast design, which we saw from an RF3D robot, and so we implemented their design along with a touch of our own. So we have a ground intake that also serves as a shooter, and we added a climber to be able to climb, and a line light in the back for extra accuracy. So we're getting ready to be nice. So in the previous match, they accidentally inverted the controls, so we couldn't really drive how we wanted to. So now they're just working on uninverting them.
Tyler from Team 3197.
Could you tell us about your guys' bot for this season?
Yeah, so right here we have a 4-bar intake that deploys, and when it intakes the note, we have a directional motor that's going to feed to either the shooter or what we'll eventually have is a trap mech. This shooter, once we feed it to the shooter, it'll articulate and it'll basically be able to shoot from anywhere within the wing. And then during endgame, we have a inverted telescoping arm that's able to come all the way down and get us as close to the trap as possible.
Thank you. I'm here with Alex from programming. And Alex, could you tell us what you're doing?
So currently I'm working on the ground intake system on our robot, and I was working on the climbing subsystem and command system for our robot, which is active right now. So what I was working on was the ground intake, so we can actually pick up notes from the ground and put it into our shooter system, and I'm working on building the subsystem and command base for that so that we can program it to the controller and get everything running.
Thank you. Here with Alex from Design. And Alex, could you tell us what you're doing?
Yes. So currently we are trying to finish up our shooter design. This is our main assembly right here. As you can see, we have a conveyor belt system to take our note from our ground intake that's not in this assembly and put it into our actual shooter mechanism so we can shoot the note. And we are trying to get motors put on it right now so the belts actually move. We also need some brackets put onto this, but we're trying to get that finished up as soon as possible. We also have Ryu right here right now. If you look at what he's doing, he is making drawings so Build Team can stop being angry at us for having nothing to do.
Thank you.
Yep.